Alright, so a few people commented that they wouldn't mind seeing another video. So what I'll do is I'll write a function M file, which is somewhat related to the second problem on project 3. And what this will do is this will calculate like let's say, let's be nice, let's do like a midpoint sum. Right, so again, what I'd like to be able to do is, here I am in MATLAB, I'd like to be able to do something like my midpoint sum. I'd like to give it a function like sine x. I'd like to give it an interval like say 1 to 4, and then I'd like to give it a number of subintervals like say 5. Then I'd like it to basically break this interval into this many pieces, find the midpoint for each of those, plug the midpoint into the function to get a height, multiply that height by the width of the subinterval, and then get the value, which is kind of like an approximation for the integral. So if I do it now, of course, it errors. So I'm going to go edit my midpoint sum dot m. I'm going to tell it not to show me this prompt again. Alright, so same deal as before. I'm going to do function, give it a return value, let's say fun equals my midpoint sum f, a, b, n. So I need 4 placeholders because I'm passing it 4 things. One's a function, an a, b, and a number of subintervals. Dump an end statement down here. So again, right now, function does nothing, but at least if I do it down here, it won't error anymore. There you go, it does nothing. All right, so when we do a midpoint sum, there are a few things we need, right? We need to know the width of each subinterval, right? So that I can calculate. So we could say width is, so it would be b minus a is the length of the whole interval divided by n, that's the length of the subinterval. Right? So now, when I do the midpoints, I have to start at the midpoint of the first interval. Right? So the first interval begins at a, or the first subinterval, let's be clear. So the first subinterval begins at a, but the midpoint is a plus half the width, because the width is the width of a subinterval. So we could do something like this. We could make it really nice and verbose. We could say start equals a plus 0.5 times width. That way it's a plus halfway through the width of the subinterval. And I could do end is b minus 0.5 times the width of the subinterval. Because it ends, b is the very, very, very end. The ending subinterval is the interval that's before the very end. Right? So the midpoint of that, these are midpoints, right? Maybe we should call it, let's do this. Let's make it nice. Start midpoint. This is really wordy, but that's okay. And end midpoint. It's the ending midpoint. So it's b minus half the width. So now what I need MATLAB to do is I need it to go through all the midpoints and do stuff with that. So whenever we want to code something that goes through a certain number of steps, and we know the number of steps, like here it's n. N is the number of subintervals, n is the number of steps. If you know it, it's a for loop. If you don't know it, then generally it's a while loop. So what we're going to do is we're going to do for, and then I need a variable, let's say x. And so the for loop says the format is, where do I begin? Well, I'm going to begin at start midpoint, colon. Let's put some space in here so you can see. And then the next one is how far it jumps, right? So the starting midpoint is there, and then the very next midpoint is width units along. And that gets us to the middle of the next subinterval. So we're going to go in steps of width. And then we're going to keep going until we get to end midpoint. At this point, right? So look, we could do something like this. We could just put x in here, and we could end it. Right? So this will set all the stuff. It won't say anything because of the semicolons. Then it'll do the for loop, and it'll just, this x just shows you the x at each stage of the game. Right? So if we go down here, we should get 5 of them, right? Because there's 5, and they shouldn't be so pretty because the interval is width 3, so like going in lengths of 3/5. So there we go. Let me do this too. Let me do format compact. That makes things a little tighter. All right. So see, we're We're going in intervals of 3/5. We're starting at 1.3, 3/5 is 0.6, so we got by 0.6, we got by 0.6, we got by 0.6, and we got by 0.6, and we got 5 of those, so that's great. So those are the midpoints, it's just displaying those, right? Now what I need to do is I need to plug those midpoints into the function. So that would be f of x, right? So let's just try that so we can see what happens. When you're coding this stuff, don't feel bad about just like continually running and running and running as you're building, because partly it's a process of making sure things work. See, now you get these really awful values. Well, they're not awful, they're quite lovely. But these are the values that we get when x is plugged into f. Now, that gives me the height of the function at each midpoint. Now I need to take that height and multiply it by the width of the subinterval. So we go back here. This is running a bit slow. I'm going to go multiply by width. Right? So this would give me the area of each subinterval rectangle. Right? Again, we can try it. Take a look. What's going on? See, so now they're a little bit different because they're smaller because they've been multiplied by the width, which is 3/5. Right? So now what I need to do is I need to add all those up. So we did some things in the previous project where we had like a running total. So what we're going to do is before the for loop in here, I'll put some space in here. I'm going to put, let's say, overall sum. And that starts at 0. Now, this value has to, inside the for loop, has to be added to that sum. So for each iteration of the for loop, it gets added. So overall sum equals overall sum plus that. Right? So each time the overall sum gets changed to what it was before, plus the area of the little rectangle. Right? So this should do the job. We go down here, give it a go. All right, so it gave us all these overall sums. Now, we're not quite done. I said this should do the job, but I'm half right. So overall sum this is the cumulative sum as it goes. Okay? So the value that I'm interested in is this very last one, or something went a bit haywire there. Oh, it's because my sine function goes negative, so my overall sum goes negative. So that's not, my overall sum goes down, so that's not unexpected, but it's a bit disconcerting. But that's okay. So if I'm going to return the last one, what I'm going to do is I'm going to semicolon this guy. So he shuts up. And then again, like in the previous video, right, fun, this guy, fun, he's the value that's going to be sent back, right? So before the end statement, at the very end, I say fun equals overall sum. That should, and semicolon that. Save that. So let's run through this. It sets the width of each subinterval. It sets the starting midpoint as a plus half the width. That gets me smack in the middle of the first subinterval. Sets the ending midpoint at b minus half the width. That's the middle of the ending subinterval. It initializes an overall sum at 0. Then it does a for loop, which begins at the beginning, the starting midpoint. It steps in iterations of width, and it ends when it gets to end midpoint. For each time, it takes the overall sum and it modifies it by adding the function at x, that's that x value, multiplied by the width. So this little piece right here is the area of the little subinterval, which is getting added overall. Then when it's done, that all is all semicolon to be quiet. When it's done, it takes the very last value, overall sum, or the current value, the value it ends with, assigns it to fun because fun is the thing that gets sent back. Should do the job. Bam, we get an answer. Okay? So you can test this, right? So, for example, the sine curve from 0 to pi, if you do 5 intervals, you see it has area 2. Now if you go and you integrate sine from 0 to 1, well 2.033, if you integrate sine from 0 to pi, you should get an integral of 2, because the integral is negative cosine, you plug in pi and 0 and you subtract and then negative cancels and you get 2. So the more subintervals I have, the closer I should get to 2, because the more accurate the integral is getting. So if we do 50, now it looks a bit closer. What we can do is we can do format long. This gives me more digits. Oops, did that twice. See, now you can see it's really close to 2. If you did like 500 intervals, it's even closer. If you did like 50,000, let's do a million. There we go. Takes a while. All right, so really close. And then, of course, you can try this with other functions. My midpoint sum. Let's give it the function, I don't know, x times e to the x plus 3 from -3 to 10 in steps of 7, or in 7 subintervals. There's our value. Right? It's a pretty big value. Right? So again, this is an example of just doing a midpoint sum. It's kind of like the second problem. You need a left sum and a right sum, and then you average those, which is not the same as doing a midpoint sum, right? Keep in mind. So you'll need to sort of fiddle with this to create two sums. You could do 2 for loops, that's fine. Up to you. So have fun.